Welcome to The Last Fireflies, a radical climate podcast with an Eastern European focus.
Hey folks, Robbie here. We are back with another Infospill segment. Last time we talked generally about where we are with the state of the climate and climate change in the present, and we left you off with a teaser, a grim teaser about climate tipping points. So that is what we are going to talk about today. Yeah, so to kick things off, let's just try to explain or describe what climate tipping points are. They are parts of the Earth system which have a very specific behavior. We generally think about climate change in the sense that we are putting in the atmosphere X amount of emissions, and then as a response, the temperature and different parts of the climate change gradually as we increase the greenhouse gas emissions. But some particular elements of the system have this very specific behavior that if they cross a certain point, certain threshold, their behavior starts to become self-perpetuating or self-reinforcing. And after that, they have, let's say, a mind of their own. They have a dynamic that is no longer governed by the emissions. So let's say, after we cross the tipping point, after that, even if we reduce all emissions to zero, all climate forcings, as they call it in the scientific literature, the process will still unfold. No matter what we do, the process will still unfold. It's a little bit abstract.
I mean, if you can think of fire, I guess, right? And at some point, it's just, I guess it's too big. If it's a wildfire, it becomes too big and it's too difficult to stop. Something like that, but like for the whole globe.
Maybe a different analogy for just this threshold behavior. Like, for example, if we think about Arctic sea ice, the global temperature increases, the ice shrinks. So after that, let's say if we reduce emissions and the temperatures drop, the ice will recover. Okay, that's a reversible process in that sense. But if during this process, polar bear species become extinct, after that, even if temperatures decrease again and the ice comes back, polar bears will not come back because there are no more polar bears. So that's this kind of a critical threshold behavior, where if we cross a certain threshold, we have something completely different happening.
I feel like just the term climate tipping points does not sound terrible enough. Like, like it sounds too benign.
That's a good point. Yeah.
Like it should be climate breaking points.
Yeah. Well, it will take me some time to readjust my brain to this new term, so I don't promise that I will use it, but I think it's a good term. Yeah. I was thinking of another analogy that maybe helps us with the details of what a tipping point situation means. You can think about the following situation. You have two valleys separated by a hill. So Valley A, Valley B, and the hill in between, or a mountain. And then you have a ball in the first valley, in Valley A. And then you have some kind of forcing.
Sisyphus is rolling the ball.
Kind of like Sisyphus, maybe, yeah. Kind of like Sisyphus. So if you have a person, or maybe the wind blowing the ball up the hill, or maybe there's someone with a leaf blower blowing the ball up the hill, and then if at a certain point the forcing stops, the wind stops, or the person stops, the ball will roll back into the first valley. So it means that the valleys are stable states to which the system tends to go back to. But we can imagine that if the wind blows the ball up the hill, then when the ball is exactly on the peak, it gets a little bit of a more of a kick, and then it starts sliding down the other slope, the B valley, the second valley. And you can see from the example, if we then stop the wind, the ball will continue rolling towards the second valley. It will not come back to the initial state. So in the analogy, the wind or the person pushing the ball up the hill is climate forcing. We can think about that in a simplified way as CO2 emissions. So CO2 emissions are the force that pushes the ball up the hill. And after it crosses the peak, so that is the tipping point, the peak in this case, after that, even if we stop all CO2 emissions, all forcings, the ball will continue on its own towards another different stable state. And that also gives us an idea about what can be done to reverse the situation. Well, in this case, you would need the wind blowing from the different direction to get the ball back to valley A, right? But in our analogy, that would mean you would need to have negative emissions of the same order of magnitude as we have positive emissions now. So like as much as we are emitting today, that much we will need to capture in the soil or somewhere else in the future if you would want to reverse this process. So that's a kind of geoengineering that's hard to imagine. And as a shorthand, we say that for all purposes, the process is irreversible. Nothing that we do will reverse the process once the tipping point is crossed.
To picture your valleys a little, I would imagine that in Valley B, where the ball crashes, there live like very tiny beings that are crushed by the ball because the ball crashes. And then also Valley A is also affected because Valley A has no more ball, and whatever they had been doing with the ball, they probably needed it for something. And everybody is worse off, but some valley is in a worse state than another valley. Would that be appropriate?
In the analogy, we would say that the Earth or the climate is the ball, and Valley A is this habitable climate that we had during the Holocene, which was stable and favorized, the development of stable civilizations, etc., etc. And Valley B is some kind of hell, for a shorthand. It's kind of it's a hot hazard state.
Okay, so we are riding the ball. All of us are on the ball.
Yes, we are on the ball. We are on the ball.
On the wrecking ball.
On the wrecking ball, and capitalism is Sisyphus, and it is pushing the ball up the hill, and now it is very close to the peak. Generally, that's kind of the shorthand.
Yeah, but the Sisyphus's ball always dropped back, and capitalism will push this ball off the hill.
Yeah.
I mean, we wish it was Sisyphus.
It's Sisyphus, but a little twist. Yeah, so this is the basic idea of the tipping points. The rest of the segment is heavily based on this paper by McKay et al. From 2022, published in Science. At this point, I would maybe urge you get this paper, either pirate it, or if you're a student, you will have access to it through your university, or just ask on social media or ask a friend from academia. It's pretty easy to obtain. Unfortunately, it's not open access. It's a great paper from 2022, which explains, it's a review about our state of knowledge about different tipping points and some conclusions, which I will not spoil. But yeah, it's good to have the figure 1 from this paper in front of your eyes for the rest of the discussion.
I can describe it a little bit as someone who has trouble reading it. It's just like a few colors and many numbers. And there's like 1, 2, 3, 4 columns. Okay, I know how to count 4. It's four columns.
But there's a table. First the figure.
Yeah.
Before the table, we are looking at the figure. So it's a world map, and it has different points on it with some text. It shows the major tipping points. Generally, Earth system has many subsystems that have this kind of tipping point behavior. However, only a few of them are considered to have such significance that their activation will affect the global climate. So others will have only a regional effect, important for non-human animals and human societies, but those secondary ones will not affect the global climate much. So the major ones, let me just list them very shortly. The major ones are ones that pertain to the Arctic Circle, so summer and winter sea ice over the Arctic, the Greenland ice sheet, permafrost, which is the frozen earth above the Arctic Circle on Eurasia and North America. Sometimes you include boreal forests, which are conifer forests right below the Arctic Circle, which encircle the planet. So these are ones that pertain to the northern pole, of the planet. Then we have the so-called AMOC, the Atlantic Meridional Overturning Circulation. It's a very fancy name, but it just means the circulation of the oceans in the Atlantic. Then we have the Amazon rainforest, which also has a tipping point kind of behavior. And then we have the tipping elements that pertain to the southern pole of the planet, in particular the West Antarctic ice sheet, which is the more fragile one. And then there are several ones which pertain to the East Antarctic ice sheet. That's more stable. It's usually doesn't come into discussion unless we have like the worst case climate change scenario. So again, there are three kinds. Ones that pertain to the North Pole, Northern Arctic region, ones that pertain to the Atlantic Ocean and the Amazon rainforest, and the third kind which pertain to the Antarctic zone close to the southern pole of the planet. What's interesting in this paper is that it describes each tipping point, and it also gives a best guess estimate for the temperature at which they will be activated and in what way they will contribute to climate change, or to how much degrees change they will contribute in the long term. So for those of you that have the paper in front of your eyes, you can go to table 1, page 4.
May I just say that it actually, on the first page, it has like this summary. So you can probably just read the first page if you cannot read the rest.
So if you look at the table with the different tipping elements, two notable ones are the Greenland ice sheet and the West Antarctic ice sheet. These are two elements which we would say, are the most, maybe fragile is not a good word. They are more at risk.
And the corals, no? And the coral reefs.
Yeah, and the coral reefs are, they're not a global tipping point, but coral reefs are also a system which will experience a tipping point-like behavior. Yeah. And our best guess estimate is that all three of these will be activated at around 1.5 degrees Celsius, which is kind of where we are. Maybe not yet, but in 2 years we will cross that threshold. But it's very likely that they are already activated, all three of these. So that's pretty grim. On the upside, I would say that the time scale which is associated with these, I'm talking now about the ice sheets, the time scale which is associated with these is generally on the order of thousands of years. It's kind of counterintuitive because you would think that if it's hot enough for ice to melt, it will quickly melt. But there is just so much ice on Greenland. You have like an ice sheet of 1-2 kilometers thickness. It just takes a lot of heat for ice to melt. And because of this, it just takes a lot of time for the Greenland ice sheet to melt, around 1,000 years. It's slower or faster depending on how fast climate change will be or how big it will be. But that's kind of the time scale that we're talking about. Hundreds of years for sure, maybe 1,000 years, maybe more for Greenland.
So basically, whatever we're doing in like the next 5 years will affect the Earth for like 10,000 years.
Exactly. Yeah, that's the whole point, the whole issue of tipping points, that we will either activate them or not now in the following 10 years, most of them. If we do activate them, that will decide the fate of the Earth for thousands of years. To practical purposes, whatever we do after that, we will not be able to stop these processes. Maybe for the Greenland ice sheet, because it takes 1,000 years and technology will evolve in 300 years, and maybe we will be able to do something. But most likely, we are already locked into a future where the Greenland ice sheet will melt. And most likely also the West Antarctic ice sheet.
For which it says 500 years for the West Antarctic ice sheet.
Yeah, it's a bit slower. The uncertainties are very, very high because it's just hard to get both accurate data from the literature, and also our present moment is unique in all of Earth's history. Although CO2 has been larger in the past, the speed at which CO2 emissions increase is unprecedented, at least in the last 500 million years. So there is no accurate analogy in Earth's past of something like what's happening now. And so we are not sure whether, unforeseen feedbacks will be started or not. And that's why there's a large uncertainty for all of these tipping points. So if you think about these ice sheets, maybe people tend to panic less because the time scale involved is 1,000 years.
I don't. Sounds pretty terrible to me.
Yeah, it does sound terrible, but it doesn't catch the headlines as much because maybe people think like in 500 years we will find some technological fix for it. But if we go to the other tipping points which happen on a shorter time scale, then the situation is even more grim. So first we are talking about the AMOC, the ocean circulation in the Atlantic, and the second one is the Amazon rainforest. So both of these are estimated to happen on the timescale of decades, so possibly within our lifetimes. Generally, the activation temperature for these is higher. In this paper, it's estimated to be 3.5 to 4. But again, these are average estimates. If you look at minimum estimates, so the table gives both a medium estimate and also a minimum and a maximum. We should read this as the maximum means that if that temperature is crossed, the tipping point will very likely be activated. And the minimum means that from that point onward, it could be activated. So if you want to just learn about the state of the climate, maybe you are interested in averages or maximum. However, as activists, we are interested in risk. We want to prevent the likelihood of something happening. So then we need to look at the minimum temperature. We need to look at a temperature from which it could be possible for that tipping point to be crossed, because the consequences are so catastrophic that we need to prevent any kind of risk for them to be crossed. So if you look at the minimum temperatures, for the AMOC, it's estimated to be around 1.4. So it's already possible that we have triggered the AMOC collapse and it's starting to unfold. And there are signs for that, but it's still early. While for the Amazon rainforest, in the table, it's 2 degrees, the minimum. So we are likely have not triggered the Amazon rainforest dieback, but we are heading in that direction. And just as an idea, maybe people cannot picture why the Amazon would change, but it has to do with the pattern of moisture, how moisture is transported. And basically, just to say it in a very short way, it will become more dry and it's generally believed to transform into a savanna environment if the tipping point is crossed. So that's pretty scary for both of these fast tipping elements. We have not crossed them very likely, but we are getting close to crossing them, activating them. And again, it's important that once these thresholds are crossed, for all purposes, the process is irreversible. That's why we need to act now to stop any risk of these or any probability for these tipping elements to be crossed, to be activated. If you look at how much warming or cooling is associated to each tipping element, the values are not incredibly large. For example, the 2 ice sheets will contribute around 0.05 or 0.1 Celsius. It's not a huge warming. While for the AMOC, there might be a slight cooling effect for the global climate. It's kind of interesting because you think that everything has an effect of warming, and most of the tipping elements do have an effect of increasing warming, but the AMOC collapse might have a slight cooling effect on the planet. However, the key element is here, that this table assesses the thresholds and timescales and impacts of the elements in isolation. So these estimates are given considering one tipping point in isolation, making abstraction from all the other elements of the Earth system.
It's like they're just ingredients on the table and you have not put them together in the food to be cooked. But like the whole planet is like this whole boiling pot of stuff, apparently.
Exactly. And when we think about the climate, you cannot put only celery in the pot because celery is connected to carrots and carrots are connected to potatoes when it comes to the Earth system. So if you throw the celery in, it will pull the potatoes also in with them. In other words, these tipping elements, they are connected between themselves. They have some kind of interaction, which is not very well studied, but it is generally believed that these interactions will work such that the activation thresholds will be lowered for each tipping element. The time scales decreased, so they will unfold faster, and their impact, their resulting impact on the climate will be bigger than each individual contribution. So they together, they form something bigger. They inject more chaos into the system. So just to give an idea of what an interaction between different tipping points would look like. So if we take the Greenland ice sheet and the AMOC, most of you will probably be familiar with the Gulf Stream. It's part of the AMOC. The Gulf Stream carries warm water from the Gulf of Mexico up towards Northern Europe and the Arctic. So there is a balance there. The warm water travels north. When it cools, it sinks down. On the bottom of the ocean, it travels back south. And so you can think about this as a conveyor belt that transports heat towards northern latitudes. So one thing that happens is as the Greenland ice sheet starts to melt and it pours a lot of fresh water into the North Atlantic. So reminder that the ice that's in ice sheet is purely water ice. There is no salt, it's fresh water. So there is a major influx of fresh water into the Gulf Stream. Fresh water is less buoyant than salty water. And so you can see how this injection of fresh water tends to counteract this conveyor belt of heat. It puts a wrench in it. So the larger the influx or the injection of fresh water, the larger the disruption to the conveyor belt. And so that is an example of a negative interaction or a destabilizing interaction between tipping points. In this case, the melting of the Greenland ice sheet contributes to the destabilizing of the AMOC. In turn, maybe a non-intuitive effect is that as the Gulf Stream collapses or as it weakens, it transports less heat up to northern latitudes. So maybe counterintuitively, that has an effect of cooling the area around Greenland. So it has a slight stabilizing effect on the Greenland ice sheet. However, generally, that stabilizing effect is thought to kick in on a much larger time scale, and so it will probably be not enough to prevent the Greenland ice sheet to tip and to fully melt. But that's just an example of one positive and one negative, one stabilizing and one destabilizing interaction. Most interactions are considered to be destabilizing. For people who are interested to read maybe more about tipping point interactions, there's this interesting paper by Wunderling et al., published in Earth System Dynamics in 2024. So it's a recent review. But if you read the paper, you will get the general feeling that we actually don't really know a lot about interaction. So a lot of it is conjecture, a lot of it is just educated guesses, basically. So there are a lot of unknowns, as it were, when it comes to climate tipping point interaction, which can make the situation much, much worse.
Great.
Great. Sorry to be the bearer of bad news, but this is my skill. I guess it feels overwhelming to have all this information in one place, right?
Yes, and I know it's like so big, everything we're talking about, and I have so much trouble imagining everything happening. Like just all that, I have not even seen how it would look. And I just feel like I'm feeling this loss, but I cannot even grasp what is being lost.
Yeah, I know that it's also good to focus on particular species, particular ecosystems, for the grief to be specific. But at the same time, in my mind, when it's too much to hold in detail, I just think that we are basically risking everything, and there is a non-negligible chance that the Earth will become only barely habitable for humans in 200 years, maybe more. But the idea is that because of this tipping point behavior, we might be locked into a certain kind of future, regardless of what we decide to do after. And that's kind of depressing, and I could see it inducing despair. But also, what it tells to me is that us, this generation, we have such a responsibility to act because our impact on the future of the earth will be so disproportionate. And yeah, for me, sometimes it's like despair and overwhelming, but other times it just calls me to invest my life energy into this issue, because it's like you have nothing to lose. Because if we don't act, might lose everything.
In a sad way, that makes sense.
Yeah. Sometimes it works like this, When you are in the grimmest moment, talking also personally, it has been like that also for me. When I've been at my lowest point, it's also somewhere from which you can say that things are so bad that I am actually going to take a lot of risk and invest my whole life energy into this, because there is not something, comfortable that I can protect or whatever. I cannot carve a small space out of the earth for myself and be happy there, because that will also go to shit if we do nothing.
Yeah, it's like the motto, like people of the earth, you have nothing to lose but dystopia.
Yeah. So to end this segment, I will just summarize what I've been trying to explain. Hopefully I have managed to. First of all, tipping elements are parts of the Earth system that have this particular behavior, that after you cross a threshold, they get a mind of their own. They have a certain behavior that is no longer influenced by emissions. And if they are started, they completely unfold. And then of the major tipping elements, there are at least two that will be triggered already at 1.5 degrees Celsius, and at around 3, which is like a more realistic estimate towards where we are going now. At 3 degrees Celsius warming, several of them will be activated. And then, because these also interact between themselves, they lower the threshold for each other, most likely, and make each other unfold faster. And so if we activate one or two, there might be this kind of landslide effect, which in the literature is called tipping cascade. So it's kind of a cascade of tipping points. We might be locked into this kind of evolution of the Earth, this kind of cascade effect. And the risk of that, although we don't know how much risk there is, but the risk of that is that it activates kind of tipping point for the whole Earth, which will put us on a path to a very different kind of state, a kind of hothouse Earth state, which is the valley B in the initial analogy, if you remember with the ball. It will lock us into a hothouse Earth kind of state, and this path will most likely be irreversible. So as I said before, we need to act now to prevent any kind of risk of this happening. And so I'm leaving you off with this teaser for the next episode, where we will be talking exactly about tipping cascades and the hothouse Earth state based on the past temperature and CO2 record of the Earth.
Okay.
But again, before someone cuts my microphone off, let me just state it again, that information is very grim, and we might be heading for a very grim future, but it also puts the responsibility on us as a generation, maybe, or people who live today, to act now to prevent this kind of future, because it's still a choice of which future we want. And now we can
close.
Yeah.
This is not an ad, because we don't have ads. This is a fully listener-supported podcast, so please support us if you can. For the ending, to take in all of this, it's really hard, and one thing it makes me feel is that we should just be doing stuff, not so much talking. But at just another level, I think it still is important to know how to process our emotions, because you cannot do a lot of effective activism if you are in like a freeze state, or you just have like a lot of unprocessed grief or anger, and then you just end up putting it with your other activists or on their shoulders. So that's not ideal either. One thing I've heard about, and I have not actually done it, but I am familiar with the concept, it's this climate cafe concept. And it's actually just creating this circle with this meeting with other people, which is just about sharing these emotional responses to climate chaos. So it's just really based on having a small group of people who just come to this space to basically lament and just feel all of their feelings on this topic of climate. And I think, it's quite helpful because during day to day, we just maybe read this one terrible, terrible news of like some wildfire or some species being on the brink of extinction, and we just have this sadness, and then we have to go on with our day and keep working and have very few spaces in which we can put it or process it and talk about it. So to just have this circle in which, you don't have to do anything else. You just have to listen to other people's being affected by this thing that you are affected by. It's actually quite helpful, I think. Robbie, have you ever been to a climate cafe?
I have not been to a climate cafe before. However, I would say that I'm part of the small group here in Timișoara, Climate Action Timișoara, and we've been dealing with fluctuating levels of energy, mental health, etc. And it's maybe mostly due to capitalism or the constraints imposed by capitalism rather than directly because of the horror of climate change. But we have done these kind of climate cafe-like meetings where we talked about where we are and how it's affecting us. And it's been very useful because generally, I think it's accurate for a lot of climate groups that more of the talk is about how to respond to something or how to act to do X, Y, Z action, but less about how we feel and how we feel in our bodies and how we feel about. And so, I've done this, but it was more like a capitalism cafe than a climate cafe.
I think it's, especially with climate and maybe other things that hold really intense emotions. And it's really important to do because people don't talk about this stuff. So what I've organized is with the queer vegan community, we've done a death cafe because people also do not talk about that. And that's really, really heavy stuff. But if you go to this space knowing it's just a space with other fellow people, it's not a therapy space and it's not an action space. So you're not supposed to be judging anyone or solving anything. It's just to hold these things together. And even if you talk about this really, really bad stuff, if you come to it with this expectation that you will listen to others and you will be listened to, it can be helpful. And it's not difficult to organize. Like anyone can do it. You can do it online. You can just find like one friend if you're anxious to organize stuff by yourself and just organize it online. Or if you have like a space that is, eco, climate, Antifa friendly, you could ask them. I think it's a good way to start putting it on like the map of things we talk about,
Mm-hmm. Yeah. So when you listen to the episode, maybe think about organizing a climate cafe and then tell us about it if you want, of course.
Yeah, and also if you don't want, you must also tell us about it.
Yeah, if it doesn't work for you, then tell us why you think it doesn't work for you.
Yeah, that's wiser. Okay, so that's it for today. Thank you for listening to The Last Fireflies. We're a small autonomous group and we're listener supported. So if you can contribute to our Patreon, please do. This money will go to support the work we are doing on this podcast and keep it going. But not only. After we reach a certain threshold, we aim to try to distribute it so as to help grow the climate movement in Romania and then maybe even further in a bigger network in the Balkans and Eastern Europe. Thanks so much.